Hello and welcome back to Cipheros. Today we're going to begin with the Calculus 1 Crashy course. So this is all about limits. I want to make it just a little bit shorter, okay, than 10 minutes. So for now, this is the default time, okay? So I suppose that you've already taken before pre-calc. So this is like our overview of what you've learned about limits and get also some additional exercise, okay, that may be kind of harder, okay, to just warming up on this course. This is exactly cosine of x plus x. Now, what are limits about? It's basically where is going in the graph onto a certain point. So if x goes to a specific value, y must go also to a specific value. That is this notation, where f of x goes to something, okay, specifically this L, as x approaches to a c value. This is essentially what it means. This specific notation, okay, that x goes to infinite, it means that decreases. So we go rightwards always, as much as we can, as much as it's possible, basically an infinite times. No, that's because we call it infinite. Okay, analyze this. On this case, our f of x is cosine of x plus x. We can also replace this function by cosine of x plus x. There's no problem with that. Pause this video and analyze the limits. L, okay, or where y is going to can also be infinite, so it increases. Similarly, if we go to negative infinity, that is going leftwards always until infinite value, this function decreases that much that it means that it goes to negative infinity. Forever it will be decreasing. And about the zero, this case is just about looking to the graph, okay, therefore we don't have to analyze the much. And as you see, when x approaches to 0, f of x is always getting nearer to 1. Now this is time to exercise yourself. Calculate these limits. These are very basic, probably you've already seen it on pre-calc, but just to remember some concepts. Find the limit of x minus 1 as x approaches to 9. Find the limit of x square as x approaches to 5. Find the limit of the square root of x minus 1 as x goes. Notice how we read it, by the way. So pause and solve it. Now the first case, we must just plug in. It's basically just to set this 9 and then subtract the 1, and we have the result is 8. Similarly, on the parabola, okay, when x goes to 5, output the y goes to 25. And here's basically the same. When x goes to 16, that is the square root of 16, then negative 1, this is 4 minus 1, this is 3. Notice also that the limit cannot be unique. For example, in the case B, I suppose that you know how is in the x cube graph, therefore analyze each of these actually. So as x goes to negative infinity, similarly with e raised to x, okay, this goes to positive infinity, the result. So when x increases, if x is equal to 10, okay, e raised to 10 is very big. If x equal to 100, e or raised to 100 will be even greater. And the same thing if x is 1000, as x increases, e of x increases. But on this case, we have an asymptote. Therefore, if you know the arctangent graph, we know that no matter how the x increases, arctangent of x always approaches to pi over 2. It will not arrive further. Actually, it never arrives to pi over 2. Now, next concept. What if f of x is equal to this thing? Okay, how do we approach if f of x we translate it horizontally or vertically? But actually, it's just about building a function where there's inside the f set all the translations, and what is outside of x set also. So this case would be cosine of x minus pi over 2 minus pi over 2 plus 2 plus 1, which is 3. And in this case, if we approach to pi, okay, cosine of pi minus pi is 0, 0 plus 3, 3. That is not that complicated. Now, when our limits absurd, for example, calculate the limit of sine of x as x goes to infinity. As you can see, this doesn't exist exactly, but this can be also absurd because sine of x oscillates between minus 1 and 1. Similarly, with the limit of logarithm of x as x approaches to minus 1, This doesn't make sense because -1 is not on the domain of the natural logarithm of x. So if it is not on the domain or it oscillates, okay, we can say that this is absurd. It's not undefined on the case of sine. There are many values onto it. Now finally, these are the additional exercise that you can try it out. For now, we are not doing stuff analytically, therefore just graph and analyze, and I think that the hardest one would be the first one, the letter A. Therefore we're going to solve it just that on the next video. Thanks for watching. Seriously, this was very fast. That is basically calculus. Okay, it's just about repeating some algorithms, and I don't know what else to say. Okay, I am Fabrizzio Machado, this is Cipheros, Math Cipheros specifically, and we see us on the next video.